everyone. Today's lesson is 2-6 rational functions. This is some more review from Algebra 2 except for our very last example. We're going to review how to find vertical asymptotes and horizontal asymptotes. To find vertical asymptotes, we will find the zeros of the denominator. To find the horizontal asymptotes of a rational function, we will use the degrees of both the numerator and the denominator. Now, there's three different things that can happen there, so let's look at the three different things that can happen before we actually start some examples. There's three different things. You can look at the degrees. The numerator can have a greater degree than the denominator. The numerator can have a smaller degree than the denominator, or they can have the same degrees. And your horizontal asymptotes would either be, you can have no horizontal asymptotes, y equals 0, or you would put the coefficient over the coefficient. So let me just kind of give you some ways to remember that. Back in Algebra 2, some of us gave you little hints to help remember this. B-O-T-N and B-O-B-O. Botan and Bobo. B-O-T-N, Botan, and B-O-B-O, Bobo. Well, B-O-T-N stands for bigger on top equals none. Botan, bigger on top equals none. Bigger degree on the top, none. No horizontal asymptote. Bobo stands for bigger on bottom equals 0, or y equals 0. Bigger degree on the bottom, y equals 0. Bigger on bottom, Bobo. So Botan and Bobo may help you remember these two rules without having to memorize the greater than and the less than symbols. So that's just one little thing that may help you. Now, if the denominator and the numerator and the denominator have the same degree, and we'll look at some examples in just a second, the a over b means you put the coefficient of the numerator over the coefficient of the denominator. And we'll look at an example of those here in just a second. Alrighty, example 1. Find all horizontal and vertical asymptotes of the graph of each rational function, and we're going to state the domain. And I'm actually going to sketch the graph for you because I think having a visual of what's going on helps you understand things better. So we're going to find all horizontal and vertical asymptotes. So I'm going to write vertical. I like to find those first. Horizontal. And then we're going to state the domain. And like I said, I like to sketch the graph because I think it helps you understand better what's going on. So let's start off by finding the vertical asymptotes. Take a peek back at your rules. The vertical asymptotes are the zeros of the denominator. Zeros of the denominator. Well, here's the denominator, and this will factor into x plus 1 and x minus 1. And the zeros of this would be positive 1 and negative 1, which means I'm going to have vertical asymptotes at positive and negative 1. So I'm going to go ahead and put that on my graph just so that you can see. I will have, and I'm going to draw little dotted lines here, at positive 1 and at negative 1. I have two vertical asymptotes there, positive 1 and negative 1. Now I need to look at my horizontal asymptotes. Those are my three things that can happen, my three rules. But let's take a look at the degrees. The degree of my numerator is 2, and the degree of my denominator is 2. So the degrees are the same. If my degrees are the same, then I'm looking at this rule right here where I put the coefficient of the numerator over the coefficient of the denominator. So the coefficient of my numerator is 5, and the coefficient of my denominator is this invisible 1. So my horizontal asymptote will be y equals 5 over 1, which is 5, because I put this coefficient over this coefficient, and y equals 5 over 1, which is 5. So I'm going to go ahead and put that on my graph here. 1, 2, 3, 4, 5. Put my horizontal on there also. Extend this up a little bit more. Okay, so there's my two vertical and my horizontal asymptotes. Now, the domain, we've been talking about domain for a long time now. These two guys are connected very closely. The vertical asymptotes tell you a lot of stuff about your domain. Where your vertical asymptotes are located, these set up walls or barriers for your graph when your graph is going left to right. We've already talked about the fact that your graph or your equation cannot have zeros in the denominator. So your positive and negative 1 would make this denominator equal 0. So for your, as far as your domain goes, your x values cannot equal positive and negative 1, because that would make this denominator equal 0. So think about this. Where your asymptotes are located, where your vertical ones are located, that tells you what numbers cannot be included in your domain. See right here? Cannot be included in your domain. Because here's what your graph's going to look like. You're going to have a little curvy part up here, and you're going to have another little curvy part right here, and then you'll have this little kind of a parabola looking thing here in the middle. So if you're going from left to right on your graph's going from negative infinity until it gets close to negative 1, right here, close to negative 1. It's going to skip over it. It's going to go from negative 1 to positive 1, and then from 1 to positive infinity. So your vertical asymptotes tell you a whole lot of stuff about your domain. Alright, so let's move over here to the next one. Let's try the same thing. Let's list the vertical, horizontal, domain, and I am also going to give you a little rough sketch of the graph. Okay, vertical asymptotes are the zeros of the denominator. So what is going to make this right here equal 0? Positive 1. So x equals 1. I'm going to go ahead and draw that on here. Right here, positive 1. Right there. Okay, horizontal asymptotes. Let's take a look at the degrees. Now there's no x up here. Okay, so my degree in the numerator is 0 because there's no x. My degree down here is 2. So is it bigger on the top or bigger on the bottom? Bigger on bottom. Bobo, bigger on bottom. So right there, y equals 0. Look back at your rule. Bigger on bottom, and it's y equals 0. Okay, bigger on bottom, y equals 0. So your horizontal asymptote is y equals 0. Okay, I'm going to draw that on my graph also. Okay, just explain this. Your vertical asymptote and your domain are directly connected. If I have a vertical asymptote at x equals 1, then that tells me what about my domain? It tells me that x cannot equal 1, because if I put a 1 in here, 1 minus 1 equals 0, and that's a big no-no. You cannot have a 0 in the denominator. So my domain is limited. X cannot equal 1, or negative infinity to 1, u 1 to infinity. Fix that a little bit. Infinity to 1. Okay, so just so you can kind of see what the graph will look like, you will have something sort of like that and kind of like that. And we'll get some better graphs on some other ones here in just a minute. Before we actually start on this next example, I do want to refer you to the bottom of this page where it says to see page 187 for steps, for the steps to graph rational functions. Be sure to look in this book and maybe look at the step 1, 2, 3, 4, 5, the steps that you should go through. When we go through the next several examples, I'll talk you through specific steps, but that page in your book is a good place to refer to. So in this next example, we are going to find several different things here as well as sketch the graph. So let's start off by finding the y-intercept. Alright, we are going to find g of 0. In other words, we're going to plug a 0 in for the x in order to find the y-intercept. Alright, to find the y-intercept, all you do is you plug a 0 in for the x. You find g of 0. So let's find g of 0. That's 3 over 0 minus 2, which comes out to be negative 3/2. So my y-intercept is the point 0, negative 3/2, or negative 1.5. Let's go ahead and put that on the graph. 0, negative 1.5. About right there. To find the x-intercept, we find the zeros of the numerator for the x-intercept. That means we set the numerator equal to 0. Well, the numerator is 3. If I set 3 equal to 0, there's nothing to solve there. 3 cannot equal 0. So there is none. There's no x-intercept. That means this graph is not going to cross the x-axis. Okay, so we have our y-intercept, we have our x-intercept. Now let's find the vertical and the horizontal asymptotes just like we did the previous examples. The vertical asymptotes are the zeros of the denominator, right here. The zeros of the denominator. That would be x equals positive 2. Okay, I'm going to sketch that on the graph, right here. X equals positive 2. Okay, let's try our horizontal asymptotes. Remember, horizontal ones, we need to take a look at the degrees. The degree at the top is 0. The degree at the bottom, it's x to the first. Bigger on bottom, 0. Bobo. Horizontal asymptote. Y equals 0. Put that on your graph. Y equals 0. Okay, now when we did these last year in Algebra 2, that's about as far as we went, and we let you sketch the rest of this from the calculator. Just copy it from the calculator. I'm going to let you use the calculator, however, we're going to find some additional points. So like we did in the previous sections, I want you to draw a number line, and I want you to put your asymptote on here, which is positive 2. Okay, put your vertical asymptote on there. And then I want you to find a few extra points. I want you to find a few extra points on the left-hand side and a few extra points on the right-hand side. Okay, let me put on here what we are going to find additional points. Okay, so let's find some additional points. Find some additional points on the left-hand side of your asymptote, on the right-hand side of your asymptote. I'm going to pull up the calculator because it's okay if you do use the calculator and go to the table and find some points. So I already have the equation in here. Make sure you put parentheses around the numerator and around the denominator. And I already have the table up here. Now this is very interesting. Make sure that you pay attention to this part right here. Look at where x is 2, what you see in the y value. You see an error because x cannot equal 2. We have an asymptote right here at x equals 2, right there. you're not going to have a y value because we have an asymptote right here at x equals 2. But out of the table, you can scroll up and down and find you some nice points to the left of your asymptote and to the right of your asymptote. And all I need you to do is write down some of the points you're going to use. Like over here, I might use the point 1, negative 3, and maybe the point negative 1, negative 1. And over here, maybe the point 3, 3, and maybe the point 4, 1.5. Just write down some of the points that you're going to use so that you can have some nice points to graph. So let's graph some of these. 1, negative 3, and then negative 1, negative 1. So that gives you this part of the graph. And over here, 3, 3, 4, 1.5. So you can get that side of the graph. And just find me a few extra points and just write down the points that you're going to use, and you don't have to calculate them by hand. Now, even though it doesn't ask, I want you to answer this for me. What's the domain? If I have an asymptote at x equals 2, if I have an asymptote at x equals 2, what's the domain? All real numbers except 2. X cannot equal 2, so I'm going to go from negative infinity to 2, 2 to positive infinity. On example 3, we're going to go through the same steps that we just got through doing, except for step number 1, the first thing that we're going to have to do is simplify. Before we can ever get started, we're going to have to simplify this right here in the denominator because we can factor it. So I'm going to still have an x in the numerator, and the denominator will factor into x minus 2 times x plus 1. So you need to simplify all that first. The second thing I'm going to do is I'm going to find the y-intercept. And I find the y-intercept by plugging in a 0 for the x. Find f of 0. So that means I plug a 0 in for this x, and this x. So I'm going to have 0 over 0 squared minus 0 minus 2. So it's going to end up being 0 over negative 2, which is 0. So my y-intercept is going to be 0, 0, 0, 0. I'm going to go ahead and put that on there, right there. Third step, the x-intercept. For the x-intercept, you set the numerator equal to 0. My numerator is x. Set x equal to 0. Well, that means x equals 0, and my x-intercept is the same as my y-intercept, which is the point 0, 0. So let's go through the asymptotes. Let's do the vertical. The zeros of the denominator. Well, I've already factored the denominator, set these two equal to 0. So x will equal positive 2, and x will equal negative 1. X equals positive 2, and x equals negative 1. And I'm going to go ahead and put those on the graph. Positive 2 right here. Oops. And negative 1. Okay, horizontal asymptotes. Let's check out the degrees. Okay, let's check out the degrees. The degree up here is 1. The degree up here is 1. The degree down here is 2. Bigger on top, bigger on bottom. Bigger on bottom. So it's Bobo. Y equals 0. I'm just going to write Bobo because I did the work up there. Bobo. So y equals 0. I'm going to put check degrees. Okay, let's put that on the graph. Y equals 0. Okay, the last thing to do before we graph is to find some extra points. So, let's get additional points between each interval. Between each interval. Okay, so here's my number line. My vertical asymptotes are at -1 and +2. So I need to find me some points over here, some points in the middle, and some points over here. So I already have my equation in my calculator, so I'm going to pull it up for you. And look at where x is -1, I have an error. Look at where x is +2, I have an error because those are where my asymptotes are. So you would just scroll up and down through your table until you found you some extra points. And you can already see what the graph is going to look like, but I would like for you to find some extra points before you sketch the graph so that you have some nice points on there. But there's where you can get them from the table. So I chose the point, the x value of -2 over here, and that gave me -1/2. So -2, -1/2. In between -1 and 2, I chose -1/2, and that gave me the y value of 0.4. I mean, you can pick all kinds of x values that you want. To the right of 2, let's see, let me graph that. -1/2, 0.4 up here. Over here to the right of +2, I chose 3, and I got 3/4. 1, 2, 3 up here, and got 3/4. You know, and we probably should get a few more points. This will kind of give us enough to get going for right now. But if you have your table in front of you, you know, if I had my calculator right in front of me, I'd have to switch screens. This should go straight down, not curve. If I had my calculator in front of me without switching screens and I could just look at it, that should not touch that asymptote. That should get real close to it but not touch it. Okay, you could have your calculator and just get all kinds of points and just get you some nice points to plot there. Make sure your graph gets really close to your asymptote and not touch it. Okay, it gets really close to it but doesn't quite touch it. Okay, I'm going to add something to this. Find additional points between each interval. I should add here and x-intercept. Okay, because our x-intercept was at 0, which would be between -1 and 2. So make sure you add a point between your x-intercept also. So when you're looking at your table, make sure that you add a point in between here to make sure that the graph is a little more accurate. Okay, but having your calculator in front of you, you'll be able to find all the points that you can possibly need. Alright, moving along to number 4, we're going to start it out like we did the last one. We're going to start off simplifying and see what happens. So if we factor the numerator, x plus 3 times x minus 3, factor the denominator, x minus 3 times x plus 1, and we try to simplify. I notice that I have an x minus 3 up here and an x minus 3 down here that I can cancel out. So I'm left with x plus 3 over x plus 1, simplified. And I will continue to work from there. But before I go any further, you need to be aware that by canceling out these x minus 3's, that is going to cause us to have a situation with our graph over here. There will be a big gaping hole in our graph where we marked out this common factor here, there will be a hole at the 0 of the common factor. There will be a hole at the 0 of the common factor where x equals 3. Okay? Because x equals 3 is the 0 of the factor x minus 3. If you set x minus 3 equal to 0, you would get x equals 3. So when we look at the graph, there is going to be a hole, an open spot, okay? A hole, an open spot in the graph, a gap at x equals 3 when we get there. But for now, we are going to, okay, after we simplified, that's what we just did, we simplified. Now we're going to continue like we did. That's supposed to say like. Continue like we did on number 3. Alright, so let's continue on. Continue like we did before. The next thing we're going to do is find the y-intercept. To find the y-intercept, we are going to find f of 0, which means we're going to plug 0 in for all of the x's. So go plug a 0 in here. 0 squared minus 9 is negative 9. 0 squared minus 2 times 0 minus 3 is negative 3, which is 3. So your y-intercept is the point 0, 3. Put that on your graph. 0, 3. Okay, let's find the x-intercept. To find the x-intercept, you set the numerator equal to 0. Alright, here's my new expression. It's simplified. So set your numerator equal to 0, and so x equals negative 3. So there's your x-intercept. Negative 3, your y value is 0. Put that on your graph. There's your x-intercept and your y-intercept. 0, 3, and negative 3, 0. Okay, vertical asymptote. Vertical asymptote is the 0 of the denominator. What makes the denominator equal 0? Negative 1. So x equals negative 1. Draw that on your graph. Horizontal asymptote, look at the degrees. The degree of the numerator is 1. The degree of the denominator is 1. Okay, I'm just going to write degree 1, degree 1. Now the coefficient here is an invisible 1, and this coefficient is an invisible 1. So my coefficient over my coefficient, it's going to be y equals 1 over 1, which is 1. So y equals 1 is my horizontal asymptote. Put that on your graph. So there's my y-intercept, my x-intercept, my vertical asymptote, and my horizontal asymptote. So the only thing left to do is additional points. So go to your calculator, type in your equation. Be sure to put parentheses around the numerator and the denominator. And we're going to find some additional points. I'm just going to write down some of the additional points that I used. I used negative 4 for the x value, and then I got 0.333, which is 1/3. Negative 4, 1/3. Negative 2, negative 1. So plot that. 1, 2. Oops, sorry, scratch that. Don't look at that one. Maybe I can get rid of that. Okay. 1, 2. 2, 1.67. Stop there. Don't graph all of that one. Okay, I'm going to pause this. Okay, real quick, I'm going to show y'all something in the calculator. The reason I stopped here, or I wanted to pull up the calculator, is instead of, some of you will be tempted to plug in 3. Remember, we're going to have a whole at x equals 3. Now, if you go put this in the calculator, always plug in the original. Okay, original in calculator. Okay, original, not what you simplified to. Plug the original in, because I want to show you what happens here. Okay, plug in the original. Now, when you go to your table, when you look where x equals 3 down here, you have an error, and that's because we're going to have a whole. You also have your error at your asymptote. But when you go to the graph, it's hard to see, and you have to kind of zoom in. I am on zoom decimal. I like zoom 4 for the window. But I want you to look real closely at x equals 1, 2, 3. Go up and look right there. See that gap? See that space? There's your hole. There is a gap. There's a missing space right there, and you have to look real closely or you'll miss it. But there is a gap in your graph. So when we graph this over here at 1, 2, 3, wherever x would equal 3, right here, we need to leave a hole. We need to leave an open space. Okay? So right there, make sure you leave a hole in your graph. Okay, this is our last example. I know this has kind of been a long lesson. Most of this has been review, except for this part. This is going to be new for most of you. We're going to have a slant asymptote. That means not vertical and not horizontal. Well, we may have vertical and horizontal, but we're going to be looking for a slant asymptote there. And the way we know if we have a slant asymptote is that the numerator is exactly 1 degree higher than the denominator. Then we'll have a slant asymptote. And the way we find it is we use long division. So check this out. My numerator is 1 degree higher than the denominator. So we're going to divide to find the slant asymptote. So we're going to do x plus 1 divided into x squared minus x, and then I'm going to put my plus 0. So let's do long division real quick. How many times will x go into x squared? Well, it'll be x times, so x times x is x squared. X times 1 is positive 1x. Draw your line and subtract. And I like to show a different color here when I'm subtracting. So combine those down. Those are gone. This is negative 2x. And bring down the plus 0. Start the process all over again. What do you need to multiply x by to get negative 2x? Negative 2. Multiply. Negative 2x. Negative 2. You're subtracting, so distribute the negative sign. Those cancel. Get positive 2, and there's nothing else to bring down. When you're finding slant asymptotes, it doesn't matter about your remainder at all. Okay, it doesn't matter. This is what matters. This is going to be your slant. I can't write here. Slant asymptote. Okay, so the way we're going to write that is y equals x minus 2. That's the equation of your slant asymptote. The equation of the line, y equals x minus 2. Doesn't matter if we have a remainder. If we do, fine. If we don't, fine. Doesn't matter. This is our equation. So before we do anything else, we can go ahead and graph this line. X minus 2, start down here at negative 2, up 1 over 1, up 1 over 1, up 1 over 1, and cannot draw very straight lines on here. This will have to do. It's supposed to be a straight line. So there's our slant asymptote. So let's go real quick through this and do all the other stuff and finish it up. Y-intercept. find the y-intercept by finding f of 0. 0 squared minus 0 is 0 over 0 plus 1, which is 0. So that's 0, 0 right there. Let's see, let me put over here that this was the y-intercept. That's what we just found. Alright, let's do the x-intercept. Set the numerator equal to 0. So x squared minus x equals 0. Factor. Set that equal to 0. We're going to have 0 and 1. I'm going to have two x-intercepts. I'm going to have the point 0, 0, and I'm going to have the point 1, 0. Because these are x values here. X is 0 and x is 1. So there's 0, 0, and there's 1, 0. Right, vertical asymptotes. Zeros of the denominator right here. X equals -1. Right there. Vertical. Horizontal. Check out the degrees. The degree up here is 2. The degree down here is 1. Bigger on top or bigger on bottom? Bigger on top. So that's a button. Bigger on top is none. That means there is no horizontal asymptote. So now all we need is additional points. I'll just try to finish this up real quick. Find you some extra points in your calculator. I'll put a few on here real quick. I used -2, -6, -2, 1, 2, 3, 4, 5, 6, -1.5, -7.5, which is off my graph a little bit. And what you get is you get this little curve right in there. And then up here you get something like that. Okay, make sure I'll write them down here. -2. Oh, sorry about that. -2, -6, and then -1.5, -7.5. So be sure to write down for us whatever points you're going to use to graph, and remember you can always get them out of your table. Make sure you use your original equation. Be very careful. Put parentheses around your numerator and your denominator when you put that in your calculator to graph. And as always, if you have questions with any of these, be sure to ask myself or Mr. Four when you're in class, and take good notes, and we'll see you in class.